Okay, so state of GeoNode. Well, I don't know if many of you GeoNode, so I will give you a quick preview of what it is in case you don't know, but it will be focused on what are the news of the recent new version that we released a few weeks ago. So we are GeoSolutions. We are core committers and maintainers of GeoNode, GeoServer, and MapStore. And we provide support services on these technologies. Okay, so what's GeoNode? Well, GeoNode is two things, let's say. From one side, it's a product, a web platform for building spatial data infrastructures and geospatial data catalogs. So it's a product that you can install and start building your catalog of data and presentations and dissemination of these data in forms of maps, dashboards, and so on. At the same time, GeoNode is a framework for building spatial data infrastructures. So it can be used as a product with its client framework and all its backend services, or you can use it, split it in its own services and build your own applications, bespoke application on top of it. And this is by design. So, and this is more and more like this. I mean, in the recent versions, we spent a lot of time designing these capabilities. So, you can create thematic maps, dashboards, geostories, and expose all this data and its metadata, because it's also a metadata catalog with ISO compliant metadata, Dublin core metadata, and expose them through its own APIs and through standard OGC services like CSW for metadata, WMS, WFS, WCS, and so on. So you bring in everything, you build even simple dataset catalogs or more complex visualization on top of them, and then distribute these visualizations and services. So basically, you take your local files, spatial files, documents like media files, PDF, and you can also integrate remote services like existing WMS services, ArcGIS, REST services, and so on, and create your catalog as data sets and documents. These are the two kind of resources. And then from these resources, you build maps, geostories, dashboards, or what we say GeoApps. GeoApps is an abstract model in GeoNode for building and implementing your own kind of applications supported with the same services that support the other applications. So all the permission systems, metadata systems, and so on. And after, in the end, you get out of your GeoNode with OGC services, REST APIs, or HTML viewers and embedded viewers that you can embed in your website, external pages, and so on. So GeoNode is a composition of services. The core application is a Python application built in with Django framework and other things. And it uses GeoServer, PostgreSQL, PostGIS, and PyCSW as external services, and more others. When you deploy an entire GeoNode stack, we also include Memcache, RabbitMQ for their synchronous systems, and so on. So it's quite a complex stack. But basically, yeah, the web platform, the core that where the application is built is this one, but then the services are directly also available from GeoServer and PyCSW. So it's an open source project. we as GeoSolutions are the maintainers, main maintainers now, committers, but we have also contributions from, for example, the Tunen Institute and the other developers. There's the community, we have a steering committee, and so the community is quite active and more active. There has been a cold time in the past years, but now we are bringing it on again, and I'm really happy for that. And this is an opportunity for us for G to meet each other. Now we are at version 4.1.0. It was released a few weeks ago. The first version of GeoNode 4, which was a big refactoring of GeoNode, where we completely rewrote some services, the REST API, and the front-end application. It was done in August, so it was for the FOSS4G past year in Florence. We presented the new version. Now we are 4.1.0, and this presentation is focused on what we did in this year. Okay. You can play with the demo instances. They are open. You can register, create your accounts, and test all the features, except the administration features, of course. And we have a development version, which is following the master branch of the, and a stable version, which is one-to-one with the stable release. So feel free to go online and test it. So GeoNode 4.1.0. First thing, we completely rewrote the importer, which is the service behind the upload system and the harvesting system. It was completely rewritten because the previous version was using was a mix of a GeoNode part and the GeoNode importer extension, which was quite complex to be kept synchronized because there were two asynchronous systems. And also we had a dependency on GeoServer extensions that didn't allow to easily customize something or extend it. So, and moreover, we wanted the data, for vector data in particular, that we brought into GeoNode to be more under control of GeoNode rather than GeoServer. So the previous versions, you gave the data, let's say, to GeoServer, and GeoServer made everything, import it, create the DB tables, and do everything. Now, things have reversed. Now, GeoNode takes control of the import procedure with its own asynchronous service. And so it does the ingestion into the DB table, make processing, pre-processing, optimizations, validation, and so on. So everything is done in the GeoNode code. And in the end, it tells GeoServer that this layer exists and creates all what is needed in GeoServer for the cartographic services. And we have a new orchestrator of this complex flow that takes control of it in a transactional way of all the things. So we have full control in case of errors or whatever. We are able to roll back and to avoid any inconsistency or partial uploads. Another goal of the new importer was to make it pluggable and customizable. So now we have pluggable system. Every format has its own module. And you can integrate your own modules or replace the core modules with your own so that you can implement your own upload service. I mean, on top of the upload, well, the upload service is one, but you can implement your own logic specific for one or more formats if you have custom formats. An example comes from the Tunen Institute, which wanted to use the tabular data JSON specification for the import of CSV files. And they just created a tiny module in Python. And yeah, without touching the core, now they have this new format for them. And they will release it. Now we have also multi-layer formats that wasn't available before. So now we are able to also upload geopackages containing multiple vector layers, for the moment only vectors. But we also have, not released yet, but we have an example of an OSM PBF upload. So you can upload just the PBF with all the nodes and the edges from OpenStreetMap, and we can create all the, split the layers according to the tagging in OSM. So now you have a very open-ended way to create your import system, which also applies to the harvesting, because the upload is where you upload through the API or the UI, the physical file, you push it, but the same core system works for the harvesting, where a service which can be scheduled will pull data itself from sources, from external sources, and do the publishing on the reverse. So yeah, these are the new modules available in the UI. The new upload system uses the OGR, GDAL OGR, both through the Python OGR API, the OGR to OGR command line, and other services. But basically this means that we have full support from GDAL and OGR. So potentially you can have any format supported by GDAL in GeoNode. Okay, another topic is the new filters in the filters panel. We didn't port the Thesaurus filters from GeoNode 3. This was GeoNode 3. It was requested by several customers that use Thesaurus a lot. Thesaurus is an important concept in metadata, in Inspire metadata in particular, to define well-defined concepts to be attached to your resources. And so now we have brought Thesaurus back in GeoNode, and you are able to make faceted filtering on the keywords for each Thesaurus. Thesaurus can be uploaded through the Django administration, so you can take RDF files, which is a standard format to define Thesaurus. You just upload the file through the Django admin, which is a back office for GeoNode, and those Thesaurus will be exploded into the keywords and so on, and they are available to be used inside the metadata system. Now we also have brought back date filters, so we have expanded the filters in GeoNode a lot. We are going to make other improvements to the filtering system, both to also to the spatial filter that is already there, but I mean can be improved. But another important thing that we are working onto is improving the performance of filters, because they are a bit weak when we have very large numbers of resources, owners, categories, and so on. At the moment, it's not very well optimized. The implementation was a bit naive, let's say, in some parts. So we are restructuring it right these days. So the next version, which will arrive sooner than the current one, version 4.2.0, will be dedicated mostly to the optimization of filters, all the filters, and also introducing proper faceting. Because at the moment, the filter system in GeoNode is a bit different from what we usually have from faceting filters. It works, let's say, in OR. So when you select a category and you select a region, let's say, it will ask for all the resources that are either in the region or has a category, which often brings to wrong matches, so empty results. Usually we work in AND filtering, like Secan does, GeoNetwork, the others. So when you click a filters, all the filters will be updated. The counts also will be updated to only make available resources and other filters values that are compatible with the filter that you set before. So it's working in AND. And this is quite a big work, reworking of the filtering system, but yeah, we are almost there. Another big change was time series. The new upload system doesn't have the steps, the optional steps that were available before in previous versions, where during the upload, the user were suggested to make additional optional steps to configure the CRS, to configure the time series and other parts. But the way it was implemented was confusing for users. So they were stuck. They didn't understand very well what they should have done. And so we decided for several reasons to drop these steps during the upload, just complete the upload, make it very straightforward and linear, and give the option afterward to configure additional settings for the layers. So now the date time can be configured inside the metadata settings. So you flag if it has a time attribute, you select which is the time, date time field, and then you will get the features for time series like the time slider widgets and so on. Of course, one thing that we require is that you use formats that support date time natively in the field. So we are not extrapolating or parsing dates from strings, let's say. So a shapefile that has a date field will be recognized and imported as a date field. If it's a string with a date, it will be imported as a string, and you will not have the option to select that field as the date for the time series. So I'm saying this because it happened that some users asked why it didn't work. Then link the resources. Now we have a way to visualize links between maps, datasets, and documents. A dataset can be used as a layer in multiple maps. A map can use multiple datasets. A document can link to multiple layers or to multiple maps. Okay, so these relationships were still available in GeoNode 4, but there was no way to see them. So now we brought them back. And now you have a new tab in the panel, the information panel, with the link resources, with a list. For example, here is a map and the list of layers connected to the map. And the reverse is also true. If you go to the layer, you will see the maps. This is only valid for maps, documents, and dataset, but we are extending the model to make it available for any kind of resource in GeoNode, so also dashboards and geostories. So to make the relationship, the links, a foundation model of GeoNode, also in terms of fair principles, okay? Yeah, so dataset, the links to, this is the map with all the datasets. For documents, you can create links explicitly. Between datasets and maps, it's implicit, because when you create a map, you put a dataset, so it's implicit, the relationship. But for documents, you need to make it explicit. In the document metadata, you have the option to use the link to select multiple datasets or maps to link this document to. This is useful, for example, for metadata or additional documentation that you want to attach to a dataset or a map. So a PDF, or explaining the lineage or the history or how the dataset was processed. This way you can connect it to the dataset, and from the dataset view you will see all the documents that are connected, so you can have additional information directly from the dataset. Yeah, this is what I was saying before. This linkage is important both for FAIR principles, because it's a really important model that we want to extend, and we are working on it. It's not yet, I don't think it will be available in version 4.2.0 maybe, but maybe an initial refactoring will be there. And it's also important for the control of the life cycle of resources, because now, for example, if you have a data set or a map that you are using inside the dashboard, inside the GeoStories, this relationship is not being used, for example, to enforce control when you want to delete or replace a resource. So you might end up with a visualization that is broken because you have changed or removed a linked data set. Okay, so REST API is improving. We are extending it. We are changing, well, we're maintaining back compatibility, but we are finding better ways to make it more usable, more powerful. We are almost, we have covered almost all the functionality that we have in GeoNode can be managed through the API. So this is the goal. Make GeoNode even usable as a headless service. So you can implement your management system, your client, even without the integrated client application based on MapStore. The goal is that you can use GeoNode and then build your own application. I did it several times. We did it. A few days ago, I did a test with Flutter. You know Flutter, the framework for mobile application. And I did an example for a customer where I built in a couple of hours, I built a complete application completely based on GeoNode REST APIs. I was able to search data sets, visualize them, query them, and so on. So I think it's powerful enough now to be used as a backend service only. You can also, and we will extend it, the ability to integrate your own metadata and your own models to extend the API with your custom modules. So if you have your custom module, or you want to extend the information attached to the resources, you can do it without having to implement yourself the API. There are some fields in the model that are, blobs storage, where you can put your JSON or YAML information, whatever, and you can put it there and get it out and do whatever you want. We don't care. Okay, it's a blob, opaque field. And now we can also, through the API, create remote documents, meaning that you can create a catalog of documents that reference external documents instead of having to upload documents to the catalog. This is also true for datasets. You can use remote services. So in theory, you can have now a GeoNode catalog containing only remote resources. So not data that you upload to GeoNode, but just as a catalog of your services, wherever they are, okay? Other websites. And so we upgraded the reference version of GeoServer to GeoServer 2.23.0, and it works very well. We also make some fixes to the backup and restore system in GeoServer to make it more robust and integrated with GeoNode. So now the backup and the restore, I didn't mention here, but it was a big work that we did also to make it more robust and updated. So now you have a full backup and full restore system for a complete GeoNode stack of services, where, for example, we use it to synchronize staging and production environments. It's very straightforward to use. It's just a command, backup, restore. And also, the new version of GeoServer has granular control over WPS processes. So we have geofence rules to control specific aspects of each process, or each WPS process. And this is very important, for example, for direct download services provided by the WPS export service in GeoServer, because now we have control. The permissions to use this WPS export system is aligned to the permissions that you set in GeoNode for users. Okay, we also upgraded MapStore. I'm ending the time, but I'm in time. A big upgrade of MapStore. We are still late, although MapStore is our own framework. We use also in other products. The integration in GeoNode is taking more time because there are different models. The path is probably to integrate and merge the two more in the future. For sure, in a few weeks, we will make the big jump to the current version of MapStore. so that we align the versions, and we are then able to bring in new features that are already available in MapStore, like 3D ties, cesium support, because we will have 3D support in GeoNode too. So the ability to upload or ingest 3D data formats and visualize them inside its client. Well, I won't say the application context manager is another topic, okay. The future, well, quickly. Yeah, I already said in previous standard, faceting and filtering, more configurability, because it's a real a point for us to make everything the more customizable and more configurable as possible, extendable, because it's also important for us. I mean, every customer has its own needs. So instead of doing the old way to make a big thing that can be configured and adapted to all the cases, we are trying to make it more modular so that you can easily plug or unplug things. So this is the route. With the custom layouts also in terms of the viewer, the client application. We will see, I have a presentation with a lot of cases where we have customizations and how it works tomorrow. Custom download providers, this is important. This will come soon, where you can implement your own download provider. At the moment, we download the data that we own, but we will have the way to plug your own download provider. So the way you can implement your logic to provide the downloads. This is really important for huge data sets or for remote data sets that are stored in remote storages, for example. So this was implemented for a customer that had the data set stored in an AWS S3 bucket, and we need to make it private, so under the same permission system as GeoNode. So in that case, we use pre-signed URLs from AWS with volatile URLs that will last a few minutes and so on. So we designed a component to do that. And so we took the opportunity to make it a module that could be plugged. And so now you can plug your own module and define your own logic for the downloads. We are extending also the integration with the OEDC social account. So OpenID Connect, OAuth 2, it's already there. We have a lot of experience of using Keycloak, Azure ID, Auth0, whatever, LDAP. But now we extended it to make it easier to also not only authenticate users, but also to parse claims and roles and to map them to roles and groups in GeoNode. So we take more information from the JWT token and the authentication provider to configure these accounts in GeoNode.